now that we've done example 4, let's take a look at example 5 where we're going to talk about something called a conjugates. Now, if you look at this problem, you've got a situation similar to what you had in example 4, except that instead of it being like 5 times the square root of 2, it's 5 plus the square root of 2. So what I want to show you, and this is going to take a little more time, but I really don't care because it's really more important to me that you understand, is that if I do what we would initially think to do, which is where I multiply the top and the bottom by the square root of 2 because we say, well, we just want to get rid of that, right? Here's what happens when we do that is your top, you get, you know, you'll get 3 times the square root of 2. Sorry, I was going so slow. I was using the wrong controller. 3 times the square root of 2. And on the bottom, you get two terms. You get 5 times the square root of 2, because that's what you get when you multiply square root of 2 and 5, plus 2, which is what square root of 2 times the square root of 2 is. Now, I've got the same situation I had before. It's just a little different, but I've still got this radical sign on the bottom. So obviously, doing this does not work. So there's this thing called a conjugate, and what a conjugate is a two-term thing that we can use that allows us to get rid of it by using the distributive property. So the way you figure out what your conjugate is, and then I'll show how we multiply with it, is you take both of these terms and you write them exactly how they are. So you go 5 and you go square root of 2. And then all you do is you reverse the sign. So if you have a positive here, we're going to multiply by negative. All right? And then whatever we multiply on the top, we do by the bottom. Now, you might be thinking, okay, this looks really ugly, and how on earth is this going to help? So I'm going to walk you through this, and I think you'll see at the end that, oh, it's actually pretty simple, and that it's actually really a smart way of getting rid of it. So the first thing we do is when we do distributive property, you multiply that. You're used to these kinds of distributive property problems. So 3 times 5 gives you 15, and then minus, because we got a negative sign there, 3 times the square root of 2. So our top is all good right now. Now, on our bottom, this is where it gets weird. So what I want you to do is when we do problems like this, there's actually, if you go on Khan Academy and some on other things, they'll teach you how to multiply pairs by each other using this thing called FOIL. All right? Now, what it means, and I'm not going to teach you this, but if you decide you want to go learn it, go right ahead. It means multiply your first terms, your outside terms, your inside terms, and then your last terms. To me, that gets a little confusing because what do we mean by outside? What do we mean by inside? What do we mean by last? So, what I'd like to show you is just start with one thing and go to that. So, let's start with our 5 over here, and we're going to multiply that by both of these terms. All right? So, that gives us 25 minus 5 times the square root of 2. And maybe you're thinking, well, we still got a square root under the sign. And you're right, we do still have a square root in the denominator, but you're going to wait and see what happens, and then it's kind of cool. Now, I'm going to switch colors here, and I'm going to do the square root of 2 times both of these items. All right? So square root of 2 times 5 gives me plus, because it's positive, and that's positive, 5 times the square root of 2, and then minus, well, square root of 2 times the square root of 2 is 2, so it's minus 2, and you have a positive times a negative, right? So now let's simplify what we've got here, all right? The top stays the same as it is, 15 minus 3 times the square root of 2, and then the bottom, we got to clean some of this up. So I'm going to look at what I can combine. Well, I know I can combine this, and I know I can combine this. All right, so that gives me 23. Now look at what happens here. I'm going to go to, I'll circle these. Look at this term and this term. And hopefully you recognize that they're exactly the same, except they're the opposite of each other. So effectively what happens, and the reason the conjugate works, is it cancels them out. So your finished answer is now 15 minus 3 times the square root of 2 all over 23. So the conjugates work. They do a great job. You have to know a little bit about combining things. You can only add and subtract radicals that have the same number under the radicand. That's what that's called. And we'll talk more about this tomorrow in the lesson we have there. But all you need to know for today is that however you look at it, these cancel each other because they're the same thing except they're opposite signs. So that's why these conjugates work. So I'm going to stop the video now, and we're going to have a part 2 where I do a couple more examples with you guys.